Hello my dear students, welcome to the class of 11th English Medium. The subject is Statistics, Chapter 3, Measures of Central Tendency, brought to you by Vitan Sir. Previously I have completed the exercise 3.1 of the video of which you can see on the top right corner of your screen here. This time we are starting with a new concept, that is combined mean. As the name suggests, it actually combines the means of various groups. Let's see how. Let's suppose that we have averages of two groups of observations and we want to know average of both the groups as a whole. That means we have separate average of group A and group B, but I want to know the average of both the groups combined, and I don't have actually individual observations. That means I don't know individual values of both the groups. I just know their averages and their strength. Let's take an example. For in a school, there are two classes, class A and class B. The white boys suggest the class A and yellow boys suggest the class B. But for example, I know the average age of the class A students and the average age of class B students. As we know, in the class A there are 4 students and in class B there are 6 students. What if I want to know an average age of both the classes combined, that is 10 students? I don't have their individual ages, I don't have any other data, I just have the average ages of both the separate classes with their strength, and I want to calculate a combined average. So in this situation, the combined mean comes into play. Suppose x bar 1, x bar 2, x bar 3, x bar k are the means of k groups having n1, n2, n3, nk observations respectively. That means from x bar 1 to x bar k are the means with the number of observations n1 to nk. And what we can do with that observations is that we can calculate the combined mean. The formula is x bar c. You need to multiply the respective means averages with the number of observations. That is n1 observations are to be multiplied with the x bar 1 and 2 observations are to be multiplied with x bar 2. So respective observations are to be multiplied with their means and they're added, and then it is divided by all the observations, that is observations for first group, second group, third group, and so on. So basically you get a total of all the observations divided by the total number of observations. So it is basically a very simple method, but it seems difficult because we are not very sure about how to do that. Let us just take some illustrations to understand how can we work using this particular method. Let us start with illustration 10. A factory owner knows that mean monthly production from January to March is 350 items. Then same thing from April to August is 254 items, and then from September to December it is 315 items. We have to find the mean of the monthly production during the throughout whole year. That means we have been given data into 3 separate groups. We don't know individual production of January or September or April or August or anything. We just know that the average of first group is 350 items, average of second group is 254 items, and average of third group is 315 items. Using this data, we have to calculate an average of whole year, monthly average of the whole year. I am just going to prepare a table here to make the things simpler. Particulars, mean, and the number of observations. So observations are to be denoted by n. Mean is of course x bar. Now the first group depicts data from January to March. We know that the mean, the average production during January to March is 350 items. Now how many months are there from January to March? That's January, February and March. 3 months. So number of observations of the first group are 3, that is 3 months. Second group is from April to August. The average of April to August is 254 units or items, and then number of months from April to August will be April, May, June, July and August. That makes them 5 months. In the last group, that is September to December, the average of items is 315 and the number of months here is September, October, November and December, makes them 4 months. And when you make a total of the observations, you will see that 12 months are there. That means we just have to find the data for 1 year. Start by writing down the formula here, that is X bar C. C means combined. Just write the formula as it was given in the initial slide. Next, we have to put the values according to our groups here. How we are going to do that? The observations are 3, 5 and 4, and these observations will be multiplied with their respective means and then added. That means 3 into 350 plus 5 into 254 plus 4 into 315, and divide by, we are going to make a total of all the observations, that is 3 plus 5 plus 4. I hope you guys are getting what I am doing here. Now first multiplication and then addition. That means first multiply the observations with the means, that is 3 into 350, 5 into 254 and 4 into 315. So you will get 3 separate additive values. Divide by 3 plus 5 plus 4 is 12. When you add the numerators, you will get 3580 divided by 12. The answer will be 298.33 items of units. That means the mean monthly production throughout the year of a factory is 298.33 units, or you can also call them items. So this is how we calculate a combined mean using the available observations and the available average values. Let us just take another illustration to make it clearer. Illustration 11. The ratio of women and men employees in an office is 1:2. If the mean ages of women and men employees is 34 and 37 respectively, we have to find the mean age of all the employees of the office. Okay, once again I am going to prepare a table here, starting with particulars and then mean and the observations. Naturally, here only two groups are there, men and women. We will start with women because that is the given value first. Now the mean age of women is 34, whereas the number of observations are not actually given, rather a ratio of observations is given. What I am going to do, I am going to take that ratio directly as the number of observations. That means women and men are 1:2. So women I am going to consider as 1 and men I am going to consider as 2. There is no issue in doing this. You will get a perfectly same answer. So women I am going to consider as 1. The second group here is men, and their average mean age is 37 years and their ratio is 2. So I am going to consider the value of n for men as 2. Once we have got these values, we need to multiply observations with their averages and then add them up. So we will write down the formula first. As usually, never start without writing down the formula. Always start with that and then put the values in the equation. It will be helpful in remembering the formulas as well as not making any mistakes. We will put the values here. Observations for women is 1 multiplied by 34 is the mean, and for men 2 into 37. In the division, total of observations, that is 1 plus 2. So 1 into 34 is 34 and 37 2s are 74 divided by 3. So first add it up, 108 divided by 3. The age, the average age of the employees working in the office will be 36 years. So just write the statement stating the same thing. The mean age of all the employees of the office is 36 years. Okay guys, I think you are getting a hang of it. Let us take a bit of a different example here. You will get to know how it works that way. Illustration 12. A team, a cricket team of course, has to score with a run rate of 8.25 in 20 overs to win the match. I hope you guys know the run rate means a run per over. The run rate at the end of 12 overs is 7.25, of course a lot lower than actually intended. What should be the least run rate to be maintained in the remaining over to win the match? I think you guys, if you learn this particular sum properly now, you will be able to estimate practically the future match runs. For example, if India is playing against Pakistan and we have a one day ODI match that is 50 overs and 30 overs has already passed, you will be able to estimate how many runs should be scored per over to win. And I think that data is actually provided by the BCCI on the screen already. So this is how they calculate that particular thing for each and every ball. So just try to understand this sum thoroughly. It will be actually useful in the practical life also. So I'm just preparing a table here. Let us understand the question properly first, but particulars, mean and the observations, that is n. Okay, a team has to score with a run rate of 8.25 in 20 overs. Now 20 overs basically means that this is a T20 matches and the total number of overs here are 20 and a team needs 8.25 run rate in 20 overs. Now that means they have already given us the final run rate, that is the combined mean. What I am trying to say here, that this is not a particular group, this is as a whole. Okay, we have group 1, we have group 2 and then we combine them to find the whole value. They have given us the average required run rate of the whole group, that is 20 overs. So total number of overs, the grand total is 20 and the actual combined mean is 8.25 because that is our target. Now we are dividing our values into two groups, that the first group is run rate at 12 overs. Okay, so that is the first group. The first 12 overs depict the first group and that run rate is already given, that is 7.25. So number of observations for the first 12 overs will be 12. Now just to think practically, that a match is of 20 overs and the first 12 overs are already done. So how many overs are left? Keep that thought in your mind. The second group, that is required run rate for remaining overs. Okay, the first group was run rate at 12 overs and second group, which is the question actually, is required run rate for remaining overs, which we don't know. So the question here is not to calculate combined mean. The question here is to use the combined mean to calculate the average of one of the groups. I hope you guys are getting my point here. So that thought which I told you to keep in mind. How many overs are left? 8 overs. So now my first group is run rate at 12 overs, that is mean 7.25 and number of observations 12. My second group is required run rate, which I don't know, with number of observations 8. And my combined mean, that is x bar c, the run rate of the overall average match is 8.25 with total number of observations combining the whole match is 20. Let's put this data into our equation here. That is x bar c is equal to, you know the formula here, right? So I am not just going to repeat it, but how to put the value. Now x bar c is the combined mean. So in place of x bar c, that is on the left hand side of the equation, put the value 8.25. Then for the first group, you know that it is 7.25 into 12. So 12 overs into 7.25 run rate plus. You know the overs, but you don't know the run rate. So you will just write an unknown value, that is x. Okay, so this is a sum which includes an unknown variable x here. So the required run rate is what we are supposed to find, which we don't know. So overs, observations will be multiplied with the unknown mean. That mean I am assuming as x, divided by total number of overs in the match, that we already know, 20 overs. So this is how our equation is going to play out. What we are going to do first is that in the right side of the equation, in the numerator, we are going to multiply the values. So 8.25 will be as it is. 7.25 multiplied by 12 will be 87 runs. That means in the first over they have actually scored 87 runs. 8 multiplied by x will be simple 8x, nothing new there. In the next step, I am going to shift the 20 in the denominator to the opposite side of the equal sign. That is, I am going to multiply 20 with 8.25. When I multiply these two values, I will know actually how many runs are required to win the match. So 165 runs are required to win the match, of which 87 runs have already been done. So 165 minus 87, that way I will know that out of 8 overs I am supposed to score 78 runs. Total required runs are 165. 87 runs have already been done. Remaining overs are 8. So 78 runs are required out of 8 overs. So how many runs are required out of 1 over? That is 78 divided by 8. X is equal to 9.75. What is X? Required run rate for the remaining overs. So the run rate of at least 9.75 is required to win the match. So in the remaining 8 overs, if we maintain at least a run rate of 9.75 runs per over, we will win the match. Quite practical sum it is. Just try to understand this again. In case you don't understand it, just rewind the video. I have tried to explain it at length with a practical example so that you can grasp the situation very well. Okay, moving on to the second concept of this tutorial, weighted mean. Now why weighted mean? Let's see. When observation of the data has varying level of importance, that means the observation, some observations has high importance, some observation has low importance, we cannot use arithmetic mean, because arithmetic mean gives equal importance to all the observations, which cannot be done here because observations have different level of importances. Therefore, what we can do is we can calculate a special average named weighted mean to assign weights to the observations depending on their importance. So observations with higher importance will get higher weights. Observations with lower importance will get lower weights. These weights are numerical values assigned by either us or assigned by someone else to be used in calculation of the weighted mean. Let's suppose that W1, W2 up to Wn are various weights which are assigned to the observations x1, x2 up to xn. That means that W is the weight and x are the observations. So just like in combined mean we apply observations, number of observations to averages, in this question we apply weights to each and every observations, and the weighted mean formula will be x bar w stands for weighted, w1 x1 plus w2 x2 plus dot 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 plus wn xn divided by w1 plus w2 plus dot 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 plus wn. So it might seem a very similar formula to combined mean, but in combined mean formula we use n and x bar, while in weighted mean we use w and x. So there is a huge gap between the two formulas here, but just try to remember this formula as it is. This is quite an easy concept and a very similar to combined mean. Therefore let's just take one illustration to understand this concept. That will be illustration 13. A student gets 35 marks in theory paper, 15 marks in practical examination, and 5 marks in oral exam of a subject. The school gives weights as 4, 2 and 1 respectively to these types of examinations. We have to find the average marks which are scored by the students. Now as you can see, the numerical values 4, 2 and 1, That means 4 weight, 4 importance is given to the theory paper, 2 importance is given to the practical examination, and 1 importance is given to the oral exam. So that is our weight, and the marks scored by student is our variable, because we are supposed to calculate the marks. So marks is our observation or our variable x, and the importance given is our weight or w. So once again I will be preparing the table here to explain it properly. Particulars, marks, that is x, and weights, that is w. Okay, so first is theory paper, in which student scored 35 marks and its weight is 4. Second group is practical paper, where he scored 15 marks with a weight of 2. And the third one, oral paper, scoring 5 marks with a weight of just 1. Same thing we have to do. We have to multiply the respective weights with its marks and then add them up. The formula which we must write before starting the sum, and put the values down one by one: 4 into 35, 2 into 15, and 1 into 5. Add them up, divide by total of the weights, that is 4 plus 2 plus 1. Always follow the DMAS system of calculation. Start with multiplication first. 4 into 35, that is 140, 15 twos are 30, and 5 ones are 5. Divide by 4 plus 2 plus 1 is 7. So add them up, 175 divided by 7. The answer here will be 25 marks. That means depending on the weight, the weighted mean of marks of this student is 25 marks. I hope you guys got this properly. If any doubts, just replay this video and watch it again. In the next tutorial, I am planning to start with exercise 3.2. It's a very small exercise with just 4 sums, but it will be quite informative. Welcome students to Vitan's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.